Hello friends, this is the first part of my tutorial for writing an operating system from the scratch. So in this tutorial we are going to cover up the Makefile, how to create a Makefile, what is a bootloader, how the bootloader file looks like, and nasm, and some of the few things. So this tutorial is not intended to show you the theoretical or give you the theoretical knowledge of the operating system. You must have a knowledge of operating system and how does it work. So we are basically going to cover up the coding part essentially. So let's just start with a bootloader. This is a quick introduction. Okay, so here is a bootloader code. org0 is a directive which is in nasm, so it is just provide the offset. Bit 16 is actually tells the assembler that we are going to operate in a 16-bit real mode. Actually, when the PC start, when the PC boot, it operates in a 16-bit real mode. So we have to be in 16-bit real mode right now. We cannot use C language because it uses the register which is a 32-bit register. So we have to use assembly first when the PC start. So that is why this code is in assembly language. Then we are providing it to jump to a label. Label is a boot 1. So where is the label? Here is the label. Jump to a boot 1. Clear the interrupts. Actually it is just disable the interrupts because we are going to set up the stack and the register. So first of all, just disable the register. We don't want disable the interrupt. Sorry, we don't want the interrupt right now when setting up the stack. And when the bootloader and when the PC start, it just loads the bootloader code at an address which the code segment is the 000 cross 707C00, and instruction pointer is pointing to the first address at the first instruction at this address. So the code segment is, we have set up the code segment, we are assuming that the file will be loaded at this particular address. So because all the data is here, so we need to make ensure that the code segment and the boot segment is in the same segment. So that is why you see that we are setting up the data segment and extra segment by ourselves. Then we are also setting up the stack pointer and the stack. Just if you don't know why are we doing this, just go through the real mode memory mapping. You will see that 0 cross 500 to 0 cross 7C00 there is a free memory, so we'll use that free memory. Then we'll call a print command to print something so that we know that something is working. And this is a signature for the bootloader. The BIOS always look for this signature. And this is times is actually just it actually make up the file to 512 bytes, and whatever left out of the 510, it just makes everything 0. So we don't, because we want the last two bytes to have something like 0 cross AA and 0 cross 55. We can also say this DB 0 cross AA and then DB 0 cross 55. Both are one and the same thing. The last two bytes should be 0 cross AA 55. That is the main point. So we are done with this. Then we have a print label here. When we call up a print, it will just run this command lodsb, which is a keyword which full form is load a string byte. So what it will do is, it has two things to do. It will load up the SI. You can see here we have SI comma message. We are actually loading the byte pointed by this label into SI. So SI will, the lodsb will do what it will do is, like, it will load up the SI register with the bytes we have provided here, and it will also increment to the, it will also point to the next byte, and also it will load up the AL register. So just go through the how does the print work. If you want to type a character interrupt 0x10, how does it work? Just go through it. So then we also have a 0x0. Actually we can also make it 0. For example, this is just a notification. Okay, we are now, this is the end of the byte, so we will look for the 0 here by OR statement, and then we will jump to, and if it is there, then just return back to where we call the print label. So it will return here and then hold up the system. This is it for it. Compile it with nasm #bin boot.asm #boot.bin. You will get a binary file with this command. But I also want to create an image file and then load this image file with a qemu. So what I will do is, I have created a Makefile. So here is the target. Actually boot.bin depends upon the boot.asm, and when I give it a command for say make qemu, what it will do is, it will search for this qemu, and it will, okay, now the make will generate something. It will first figure out, okay, it is dependent on boot.img, and it will search for the boot.img command, and boot.img is here. Again, the boot.img, that is the image file, is dependent on this boot.bin, and then it will search for the boot.bin. So what happens is, when I type make qemu, it will first of all run this command, then it will, when it has solved this dependency, it will come here, then it will do this, it will just write this command, and after that it will come here. So dd is a Linux command, device driver, and just search for #div #null, what is it, and we are creating a boot.img image file which is of 512 bytes. See, boot block, I think boot size, sorry, block size. And then we are this if is input file. So input file is boot.bin, and then we are writing this input file to this image file we just created, boot.img. So we have, what we are doing is, we are just transferring all the contents of the boot.bin into the boot.img. Now if it is, now when this will be done, we will just load up the qemu with #fda, which is essentially a floppy disk with boot.img, and we will ask it to boot from this device. So let's just try to run it. First of all, let's clear everything here. So make qemu. See, it showed me preparing to load operating system, which is just we created here. So let's just first go through all these things. As I told you, as soon as you write make qemu, it will first of all see, okay, it depends on boot.img, and boot.img depends on boot.bin, so boot.bin depends on boot.asm, and if the boot.asm is there, it will, if it is able to find the boot.asm, then it will run this command. So the first command should be nasm. So here's the first command which ran. Then it has to create a when the dependency is solved, then it will look for boot.bin. If it is solved, then it will create a boot.img file, and then it will copy the contents of the boot.bin into the boot.img. See, it has done here. You can see it created a boot.img file, and then you can see here 512 bytes copied. So it basically copied that, and then we write qemu #fda. So it ran here. So this is just a normal bootloader. Thanks for watching this tutorial. We will keep updating you. Bye bye.